So we're a positive group. Let's begin with the positives. This one really used to impress people, less so now. The data are big, right? There's a lot of data, and the rapid increase in data, it co-occurs with alongside the remarkable increase in computing power. Yeah. So in 2012 alone, there's more data collected than all previous years of human history combined, according to some estimates. And back in 2012, that was really exciting people. Now it's a mixed bag. Maybe you've begun to play with large data sets. You realize they require different types of stewardship and wrangling, and pose simple logistical challenges. And maybe you realize that if you have some kind of imperfect data, having a lot of it isn't necessarily a panacea. And so the fact that it's big is great. We can aspire to do, even in some cases, population level analysis, which really turns fundamentals of sampling on its head. Although the opportunities to do genuine population level analysis seem to be slipping away, and I'll have more to say about that in a few minutes. A second kind of key positive about digital trace data is that it's always on. Here we have the example of Tahrir Square and the various social media platforms that were used in the uprisings that were part of the Arab Spring in Egypt. And the idea here is, if we follow the conventional social science model, we have to kind of anticipate the things in the world that we want to study. We have to go out and design a careful study. We have to we have to observe some social phenomenon and develop some hypothesis, and then go out and design a study to test it. On the other hand, many of the things we are most interested in studying as social scientists are things that are more or less unpredictable. Things like collective revolts or revolutions, or other more spontaneous or emergent phenomenon, especially at the group level, where we really need not only data that is naturally occurring, if you will, but also data that is kind of embedded in real social relationships. So a key feature of digital trace data is that it's always on. We can very often look at old problems from a new lens. Now, of course, there's going to be many caveats about this as well, and I'll have more to say about Tahrir Square and social media for the study of revolutions in just a moment. A third kind of key feature, and something that's been celebrated by people in the field, is that digital trace data are very often non-reactive. So what does that mean? We can collect data points, or digital footprints, as you might call them, that describe some type of socially undesirable behavior. So here we're looking at some data from the data scientist Stevens Abramowitz, who's written a very popular book that looks at how Google search data reveal that everybody lies, meaning that most people are Googling things that are socially undesirable, often to large and surprising degree. And there's these kind of neat kind of toy examples. We have other examples of various kinds of health behaviors. I've done some work using Google search data to track searches for pro-ISIS related content, for example, and have been able to begin to look at the pre-radicalization stage of internet radicalization using some of these data. But again, they come with huge caveats about not knowing who's doing the searching very often, or at best, having aggregate measures of who's producing the data. Often these data are also very opaque insofar as the way that they're created by social media platforms is not very well specified, especially Google. A fourth kind of key feature of digital trace data is that they capture social relationships. So, one thing, if any of you are familiar with network analysis, or if you've ever read a study that has some kind of network data collection component, one of the most vexing things to do as a social scientist is to try to figure out how to measure and observe a social relationship. So you may be familiar with something like a name generator, where you might ask a survey respondent to name the 3 to 5 people who they would go to talk to about important matters, or something like that. Turns out most people name one person. There's kind of all sorts of biases in terms of who that person names. And even more importantly, we're still left with like small little snapshots and slices of the network rather than the global picture that would enable us to test hypotheses about the topography of the network, meaning issues of where information might spread or how social inequality might develop in a network, that we really need to test the cutting edge of our theories. And so when digital trace data first came online, many people were very excited about capturing social relationships. And of course, this is one of the ubiquitous network plots of Twitter data. This here is from the European Parliament, fascinating organization that it is. And you know, we now see many of these kind of all over the place. And I think the kind of golden age of the Twitter network plot is dying, meaning that, you know, now reviewers and wise social scientists know that the people behind these relationships aren't necessarily best friends. They may scarcely know each other. We know very little about the qualitative dimensions of these relationships. And so again, you know, a feature of this data could also be a bug. And so a lot of the work we're going to talk about today tries to develop hybrid strategies to take advantage of some of these good things and get rid of some of these bad things. So a recent example from my work is we ran a large study, a large field experiment, and we were linking Twitter data to survey data. And we discovered in one of the early stages of data cleaning that we could use the network data to look at the issue of causal interference. So if you're running an experiment, you have to make an assumption that observations are independently and identically distributed. This is something we all learned very, very early on in graduate school. And if someone in the treatment condition has some kind of connection to someone in the control condition and begins to act differently, and that treatment spills over into the control condition, we have a big problem. When we go to subtract the difference between the two, there's no observable difference, and then we wind up with bad inference. And so one way that social media data can kind of be a bug and a feature here is when you can link Twitter data to survey data, you can actually observe many of those social relationships. Maybe not the deep, intimate relationships you would want to observe if you really wanted to know who's connected to who, though we did have one married couple in our sample. You can at least begin to identify where you might be making violations of your experimental design. So these are the good things. It's big, it's always on, it's non-reactive, and digital trace data capture social relationships. On to the weaknesses. There are many. So first one, and this is a relatively straightforward one, is that digital trace data are often incomplete. So if you want to say, go study something like incivility or harassment on the internet, and years ago, you could visit Facebook fan pages and fairly easily obtain data on user behavior, users interacting with each other around, let's say, a political post. And you might make a call to an API, which is a tool we're going to talk about later that allows you to extract large amounts of, make custom data requests from online repositories of data. You might get some kind of data points that describe how many people commented on a post, and you might then want to develop some metric of incivility around this particular issue based upon the number of positive or negative comments or something like that. But very often it's the case that comments get removed or that digital trace data, despite having the appearance of being a hygienic measurement and unperturbed measurement of human behavior, often have an incomplete nature, either because of some other type of human behavior or just because of simple data transfer issues or what's known as pagination in the API world, which we'll talk about a little later. So in other words, one of the reasons we think these data are good is because we very often think they're complete or could possibly represent a population, but when we go to use them, sometimes they're incomplete, and sometimes even worse, the incompleteness is invisible. Second, this is one we began to talk about last night. For those of you who saw Alondra Nelson's talk on ongoing attempts to promote collaboration between academics and industry, we're seeing sudden shifts in the public availability of data from social media platforms. So Facebook has been in the public eye a lot. And if we look at over time, kind of how their privacy settings have changed, we've moved from a world where much of the data on Facebook, certainly not all of it, not private user networks, but at least public interactions around fan pages and to some extent groups, and even people's comments on pages that they might not have known were observable by data scientists or folks like us, could be easily collected. And now we've reached a moment, most recently last year, where we've seen a broad kind of retreat of data availability. This has happened for a number of reasons, partly probably any number of significant scandals involving data access. We've spoken already about Cambridge Analytica, but there are many others. And to some extent, Facebook as a leader in the industry, I think inspires fear in its competitors when people see the potential for things to go awry. So this is a big challenge. If you want to get Facebook data these days, you're either going to have some kind of collaboration with Facebook, you're going to have to build some type of app that gets data from users with their consent, or you can scrape a very small number of very public pages that are probably of pretty limited utility for studying a lot of important issues or the issues that might interest any of the couple hundred people who are at SICSS this year. So hopefully many of us are working on that. Social Science 1 that we heard about last night from Alondra Nelson is an exciting initiative, but also Twitter and other industry partners have begun to discuss other models of sharing data. And we have, at the Summer Institute over the last 2 years, had a variety of relationships with industry partners from Facebook, Twitter, Microsoft, and elsewhere. And we are hoping to continue to build those relationships. And it's possible that in future years, as we go forward, we can explore collective mechanisms to access data via this very group. So in the short term, it's a big downside. But in the long term, I think we'll find that many of the most important questions are going to be very complex questions that demand what Dr. Nelson last night called the army, right? The army to solve them. So if we're the army, we need to have access to the data, and we're working on that. This is perhaps the most well-known weakness of digital trace data. They are non-representative. So here's some older data from Pew. I think this is from about 2013, 2014. And what we're looking at is just demographics for a variety of different social media platforms: Facebook, LinkedIn, Twitter, Instagram, and also the broader adult internet using population. And what we see here is, at least at that time, Facebook pretty well approximated the internet population in the US, whereas Twitter skewed much more towards ethnic and racial minority groups, also at that time skewed more towards people in urban spaces as opposed to those in rural spaces, people with slightly higher incomes, people who are slightly more educated, and people who very slight bias towards liberal users at that time. And then, of course, as we look at things like Instagram, we see various other demographic shifts. What we're not seeing here is age. And the thought experiment I always love to give to students is, how many of you are on Facebook? And most people raise their hands. And how many of you are on Instagram? And most people raise their hands. And then I'm going to ask them, so where do you spend most of their time? They say Instagram, they say Snapchat, whatever. Not Snapchat so much anymore, but Instagram, right? And then, when you ask them, why don't we use Facebook? They tell you, well, my parents are on Facebook, right? And my parents are watching what I do. So what we're seeing is there are not only demographic biases, but these demographic shifts themselves create shifts in human behavior. So if we now use Facebook to study, say, some type of illicit behavior, we're on the wrong platform, right? And so these are all dynamics that we have to be really sensitive to. And I think reviewers in the social science world, and increasingly in the kind of interdisciplinary field more broadly, are really acutely aware of this. So if we are using Twitter to study something like the Tahrir Square uprisings in Egypt, who's actually doing that tweeting, right? Is it elites? Is it young people, right? Turns out when we did the kind of post-mortem of Twitter's role in the Arab Spring, we learned that many of those tweets were coming from London, right? And we're recounting things as they were happening, as they were being viewed on TV. And many somewhat now silly-seeming early papers were making claims about various properties of Twitter discourse actually influencing the trajectory of the revolution, when in fact what we were seeing is people kind of narrating the revolution, right? So we need to be really sensitive to these things, and unfortunately it's really hard to get really high-quality data on the representativeness of different platforms. There are some workarounds. I'll talk about using Facebook Insights data in a little bit. Others have used Facebook advertising data, Google Analytics data, and there's various efforts afoot to create large panels that describe in much more detail what types of social media sites people are using, when, where, and why, and also efforts to link those surveys to social media panels to get perhaps a much more complete picture of what's going on. So, digital trace data are non-representative. Then there's this issue of drift. Right? This is where I show my age. I was a proud MySpace user many years ago. I'm seeing some nodding heads, but not too many, which does make me feel old. Okay, so once upon a time, let me tell you kids, there was this social media platform called MySpace, and it was all the rage, right? It was the social media platform, I promise. This is where my undergrads are like, what planet are you from? MySpace really for a moment seemed to be poised to take over the kind of social media landscape, if not Friendster, right? And why am I bringing up MySpace and Friendster? It's because these things drift. So, even if we might want Facebook to be the kind of way that we can take the pulse of America by, say, sampling some random distribution of comments about a topic, if we're seeing things like massive shifts of young people onto Instagram, which of course Facebook owns, but nevertheless, if we're using Facebook to study these shifts, we're going to wind up with a really distorted picture of what's going on. So people are coming on and off platforms. Platforms themselves are merging, they're dying, they're changing, they're adapting, and all these things are very difficult to model. And so, what many of our early studies of internet behavior, for example, could simply be picking up the early stages of internet behavior. Maybe we were acting in a way that's very bizarre and things will level out in years to come and we won't know. This kind of drift of on and off digital platforms, but really this is an issue that goes back, in any kind of digital data source. So if we were talking about administrative data collected by governments, when did the government start developing the funding to collect the data? When did their data collection effort shift online? What changed when it did? We want our observations to be neat and independent and standardized, but very often they're not in the digital world. Another particularly vexing issue, and for me maybe the most vexing issue about working with digital trace data, is that they can be algorithmically confounded. So this is a nice paper by David Lazar, Gary King, and a co-author called The Parable of the Google Flu. Show of hands, who's seen Google Flu here or heard about Google Flu? So most people, not everyone, have heard of Google Flu. And back in 2011, the Google Flu was celebrated as one of the big success stories of computational social science. What happened? Well, Google data scientists discovered that they could track things, searches, especially Google searches, for symptoms of the flu. And when they did this, they could create very fine-grained estimates for where influenza was spreading. And they began to do this with such accuracy that it tracked the Center for Disease Control's, that's the official US body that tracks the spread of influenza. They began to track the CDC estimates really well. So up here, you're seeing Google in blue and the CDC, in orange, and the CDC in blue. And you see this like pretty remarkable tracking. And this is a point where people, particularly zealous people were saying things like, well, maybe we don't need to do influenza surveys anymore. Maybe we can use Google Flu. And then on one day in late 2012, the Google estimates nearly doubled the CDC estimates. As you might imagine, there was a lot of anxiety. What's going on? Are we experiencing a new bird flu, a new pandemic, a new burst in influenza? And turns out no. Turns out what created this spike was not some underlying shift in the spread of disease. This was a day when Google implemented a new type of advertising feature in which people who searched for symptoms of the common cold were then delivered advertisements that asked them questions like, do you have the flu, or recommended flu remedies. This then prompted those same people to search for, do I have the flu, which was then mistakenly interpreted as evidence that the flu was spreading, right? So the key idea here with algorithmic confounding is that some underlying shift in the platform can change user behavior, which then becomes reinterpreted as human behavior when it's really the result of some type of algorithmic confounding. And what's particularly concerning is, sometimes we know about these shifts. We've been able to do a kind of a postmortem of the Google flu in this nice paper that appeared in Science a few years ago. And we're able to understand more or less what happened. We still don't know the exact details. But more concerning to me are the various ways algorithmic confounding might be happening that we just have no way of knowing about. In some cases, these could be shifts that are industry secrets. In other cases, they could be the algorithms responding in ways that even the people who built the algorithms don't understand. So we've all now heard about examples of people being served ads on Facebook that are, somehow extreme or objectionable or otherwise wrong, right? And when we begin to abstract up to the ways that, machine learning has come to recast so many people's experience of the internet, this is a big problem that we simply don't have a great solution for yet. Finally, I mentioned earlier that digital trace data kind of have the allure or maybe the appearance of being neat and digital. You hear the word digital, you think, oh, it's going to be a neat spreadsheet, right? I'm going to get a nice, neat CSV, run my regression model, call it a day. As we'll see today, most of the time when we extract digital trace data, either from screen scraping or from an application programming interface or from some other means, we get really, really messy data that might come in a variety of formats that are unfamiliar for many social scientists, things like JSON or XML data. And even worse, they will involve data structures that are uncommon in social science, like lists. Lists are arrays that can contain multiple types of elements. These are very common data structures on the internet and in many social media companies and in many of the archives that house administrative data. But they are not well understood and not easily parsed or cleaned and restructured into the neat rectangular square data sets that many folks need or want to run some type of linear model or some other type of model. So a lot of the frustration of working with digital trace data for many people who have never done it before is just simply learning to both extract the data and clean the data, even after accepting all of the other limitations that I just mentioned. We began to talk about this weakness yesterday when we talked about ethics. These data are really sensitive. This is a newspaper article, or I think it's a Vox article, about something that happened on Twitter about 3 years ago. So one day I woke up, I logged into Twitter, I saw a post that had already been shared or retweeted 30 times, and it was I believe it was a Danish researcher who had scraped 70,000 OkCupid profiles and had quite audaciously linked the data and just spread it out onto Twitter. And many of us quickly kind of swarmed on this individual and said, please don't do this, please don't do this. There's any number of reasons why you shouldn't do this. The people who produce these data don't know that you could do this. The data can be linked in ways that would be an even more extreme invasion of privacy. And perhaps most importantly, you're ruining it for the rest of us, right? There are many of us who are pursuing these data with careful IRB regulation and with utmost care and really going beyond IRB standards, as we emphasized yesterday. And we're still seeing this, this type of kind of disturbing violation. And in this case, I think part of the issue is that the particular researcher wasn't under oversight by an institutional review board. And of course, we have to worry about the broader public too. As we release our tools and our data, we have to think about these kind of adversarial attacks that Matt began to talk about yesterday when we talk about these kind of sensitive data. So we both need to be worried about data getting out, but there's also logistical challenges related to handling these data. For example, a recent paper by David Lazar and co-authors shows that it's really easy to re-identify people with 3 or 4 points of metadata. And so when we begin to link these data, which is what we all want to do, we all want to link administrative data to survey data or social media data to survey data, what we begin to find is that it can become very trivial to identify individual respondents to a survey given 3, 4, or 5 data points. And this is certainly something that I've struggled with myself in my own research, linking especially Twitter data to survey data. The unknown unknowns around re-identification in the future make it really hard to follow another principle which we hold very dearly here, which is open science and transparency. And so sensitive data create kind of a twin challenge of handling it, being sensitive to the people who reproduce it, taking the user's perspective, as Matt encouraged us all to do yesterday, but also in this secondary and very important task of sharing the data. So if folks are interested in the Q&A, you can share some techniques we've developed in our lab to share the data in a way that we think strikes a balance between the privacy of the respondents and the public need for reproducible science. Another key weakness of digital trace data is a weakness of many different types of data that are naturally occurring, and that is that only certain types of people write certain types of things down, right? So you might call this elite bias if we're thinking about history, right? History is written by the elites, and if we're doing some analysis of historical archives, we always have to be mindful of this, and historians spend a lot of their careers trying to recreate what it was like to be an ordinary person at a particular point in time and in one country's history, right? So we still have that problem from all these old texts, and we also have it from newer texts. That is to say that the people who are tweeting may have some type of unobservable characteristic. Right? They might be wealthier, they might be more educated, or they might be exactly the opposite. The problem is we really don't know. We know that only certain types of people are on certain types of platforms, but we don't know exactly who shares what and why in a really systematic way. And some of the best estimates I've seen suggest that the majority of people on, say, a social media platform are lurkers. They log in, they read, they might like something every once in a while, but they very rarely post. And they're mostly there to read about the posts of the small minority of people who generate a lot of posts, right? And so even if we can be content that something like our recent study of Twitter showed that Twitter users, we were able to show that our data were vaguely representative of the US population, but when we began to peer in and see who was actually tweeting, we noticed all sorts of biases in who's producing tweets. So something we have to be mindful of if we make the assumption that something like a social media post or an administrative record or a medical record or doctor's notes or nurse's notes, these are not things that are just consistent, independent observations of human behavior. These are things that are produced by humans. So we have this type of inherent bias. We also have the old-fashioned kind of file drawer problem. People don't tend to share the results of unsuccessful research. We've all heard this problem, hopefully by now in graduate school or afterwards. And this scaled up to a broader level should make us mindful not only of the tendency for elites to produce the data, but also for most people to only produce certain types of data. So we could talk about publication bias if we were doing some kind of citation study, but more broadly, and for much of the human behavior we might care about, we should probably be more concerned about things like positivity bias. So the tendency for people on Facebook to only share good information about themselves. Your Facebook posts make you seem really interesting, but remember, dear, there are people who know you in real life. Right, we've all kind of experienced this, very rarely do you see the post like, I just lost my job and got divorced, right? You see the marriages, you see the kids, you see the, depending on your age, you see, the celebrations. So, and we could talk about whether Twitter has the opposite bias, but suffice it to say that, the types of behavior we're seeing on different platforms are a feature of the platform. And though much of my research is highly quantitative and uses cutting edge methods from machine learning and other fields, and we'll talk about some of those tomorrow, I've recently done a large study of a couple hundred Americans and did longitudinal in-depth qualitative interviews with them in order to kind of peer into the ways that people are actually using social media. And I don't have any research to share from that. I'm still writing it up right now, but I can share with you some kind of very general preliminary insights, which is that the way that we're assuming people use social media is just profoundly wrong. We hear things about how people won't say certain things on Facebook because of family members, but then will say them on Twitter, but don't somehow realize that Twitter is a much more public forum that could, for example, bring unwanted attention from an employer. So people just have very basic lack of understanding about the differences across social media platforms, let alone how their behavior could shape other people's behavior or how we might study it. So these are all pretty daunting problems. We've gone through about 7 or 8 of them now, and we could have a really good conversation about whether the positives outweigh the negatives. But at this point in the field, I think it's fair to say now that we'll see fewer and fewer papers that only publish with digital trace data, that don't somehow acknowledge one or hopefully all of these biases, even though some of them might be really hard to address, like algorithmic confounding. And so I think it really takes us back to the hype cycle, which Matt lectured about yesterday. We're really beginning to see the transition from what you might call the trough of despair. So if the Google flu predicting the CDC estimates with remarkable accuracy was maybe created the peak of inflated expectations, and like these data could do no wrong. They could increase organ donation, they could increase voting, they could improve the spread of happiness and stem the spread of depression. They could what can't they do, right? They can spread revolution, they can spread democracy. And then the trough of despair is like, okay, well, maybe not, right? We've now have all these reasons to be skeptical that the data are going to be some kind of silver bullet or a single paradigmatic shift that will transform all of our data. We're never going to get rid of the tried and true conventional forms of data collection. And what we really need to do to get out of the trough of despair, which I think despair is a strong word. I don't think we're quite despairing, but we are, I think there's a little bit of anxiety. And so the question is, how do we get to the plateau of productivity? And so for the next few parts of the lectures this morning, we'll talk about getting the data. We're going to set aside and kind of bracket a lot of these really deeply important questions. I'll bring them back in and explain some ways of possibly mitigating some of these biases or weaknesses of digital trace data as you collect them, or at least understand what they are. But we're going to spend our last section today on possible solutions, looking again at developing apps for social science research and building bots for social science research. So we've got about 3 minutes for questions. Are there any questions in the room or comments? Yeah, Kevin.
In terms of representativeness of users of different platforms, this is a really difficult problem, I think, and I think we really need to start thinking about, should we just look at who's using them, or should we weight it by how often we're using them?
Yeah.
So, yeah.
That's a really great comment. I'm just going to repeat it for people on the live stream. Kevin Munger's comment is we shouldn't simply count the number of people on the platform, but we should count how active they are on the platform. I think it's a really sharp insight. Yeah, we could potentially develop weights or something like that, like probability weights. Yeah.
So you mentioned that some of your current research that you're writing up about how people who aren't on social media, how you're studying the method that you use, which was longitudinally, qualitatively interviewing them. Can you talk a little bit more about some of the, did you consider other methods? Are there other methods out there for looking at what people are?
So in this particular study, we collected both longitudinal survey data, longitudinal qualitative interviews, and then linked all these to the Twitter data. So we have this interesting opportunity to compare the qualitative responses to the quantitative responses to the Twitter responses. And that has already illuminated some really surprising findings. So for example, the trolls are like the nicest people you'll ever meet in the interview, just like night and day. And we're doing a lot of work with good old-fashioned sociology to try to explain some of that. But another really intriguing finding is that people who are changing their minds, and we did a study which exposed people to opposing political views and expected, what we found in an earlier study, which is a strong backfire effect. And we did see the backfire effect in the quantitative data, but what we did not see is a orthogonal shift in the qualitative data. So people are telling the same stories, even though they're answering quantitative surveys the same way. And so this also raises some really interesting puzzles about what people say versus what they do, and illustrates another reason why we can't just take social media data at face value for me.
Were they face-to-face interviews?
No. Yeah, they were over the phone, unfortunately. Yeah. And that would be another interesting level, right? I mean, maybe the troll is, I don't know, even nicer. I just want to make sure, are there any questions from the live stream?
Yeah,
okay. Yeah, let me take one from the live stream and then I'll come back to Jay.
All right. So this one says, if big data, such as Twitter, is non-representative, how can we use it in an academic publication? Can you talk about how you or others have framed a research question using big data? Also, if big data doesn't have metadata, like Twitter, I believe, how do we detect non-representativeness in our data?
So the question is about what do you do when you have non-representative data and you'd like to publish this data because you'd like to one day get a job? It's a very good question and one that you should all be thinking about. And I don't think I have a single kind of cure-all solution, but one thing I would say is a lot of the papers, I've been an editor for many years, and a lot of the papers that I've seen get negative responses kind of come out charging at the old findings and say, I have this new data, and my data are bigger, and my data capture social relationships, and my data are longitudinal and natural occurring, and your old survey of 1,200 people doesn't do all those things, so everything you said was wrong, and everything I said was right. You can imagine, if you take the reviewer's perspective for a moment, what kind of response that will elicit, right? It will respond to a defensive mechanism where the focus will be on why your data is wrong and why you're underappreciating the kind of values and virtues of the old ways, right? So one thing is to, and this is good advice for any publishing, show some respect towards the people who came before you, and instead of, just claiming that you fixed all the problems, maybe, raise some new questions rather than, definitively, answering like questions which we all agree are, extremely complex. So that's one solution if your paper is about reapproaching an old problem with new data. But there is another genre of question which I think is very important and one can also get a lot of weight out of in journal publishing, which is to ask new questions about new digital spaces. And there, it's a much different style of argumentation rather than trying to juxtapose what you're doing with what's been done, which often forces you into the situation where you have to know things about the representative posts that are maybe unknowable. You can then say, look, this is a new social space. The spread of misinformation on social media or what have you, or online harassment or something like that needs to be understood with these new spaces. I recognize, and even there, you of course need to be sensitive to the fact that these aren't capturing all the human relationships, but you can give your readers or your reviewers the thought experiment of, is it possible to study X without these new data? So if you're talking about something like, what I study, political polarization, the thought experiment I often give people is, could you imagine studying that without social media? Once upon a time, of course, but now it's a much different picture. And so there, the style of argumentation is, here's a new shiny thing that I want you to appreciate with me, instead of, I'm breaking down your castle with my Twitter data. Yeah. Let me take Jared's question and then come back.
You mentioned having strategies for sharing data while also to protect privacy, while also reproducibility.
Sure. Yeah, sure. So the first thing is, I would say don't share full text data. I think that's a kind of pretty, now that's vexing because many people want to revisit the text data in some way. Some people will say you could share a bag of words, which is a data representation, for those of you who don't know, where you count the appearance of words or sequences of words that then allows you to do some forms of automated text analysis that might allow you to pull out features. But even there, I personally would worry about identification, even after, say, removing sensitive terms. And even though we have new tools in NLP or natural language processing, like named entity recognition, that might allow us to try to systematically pull out named entities or sensitive proper nouns or something like that, these are not perfect and very unreliable. And if you're trying to scale to say, like in our study, we had, I think, 2.6 million tweets or something like that linked during the study period, You know, I'm not going to read all those 2.6 million tweets. So I think sharing features of the data that you yourself create is one way. And another way is to use, you know, any of the new, like just as, you know, we have all these new problems, we have new fields studying them. So statistical disclosure techniques, there's, you know, many fine R packages now that allow you to add some noise to data, all those we learned from Matt yesterday. These two can have some kind of you know, potential for adversarial attacks. So I think it's a case-by-case thing. I mean, it's a thing where you really want to, again, go beyond the IRB limit. You want to consult colleagues. You want to take the user's perspective and share just enough data to allow people to reproduce your findings. And then, you know, Matt and I in both of our studies have explored ways of creating kind of like restricted access to the data to allow kind of researchers to go through some kind of vetting process to better analyze the data. And, you know, there's other people who are looking into advances in cloud computing to handle that kind of sensitive data access. So for example, Amazon Web Services, which many of you may use to run your analyses, hosts a part of its servers called GovCloud, which is reportedly what the US government and the CIA uses for their kind of cloud computing. And you can kind of purchase space on those spaces, which could somehow, with appropriate credentials, which are themselves, of course, easily, you know, violated, you know, create some kind of safer space. But I think, you know, the illusion of like perfect confidentiality and anonymity is, you know, it's something where we continue to discover you know, it should be our goal, but it's going to be really difficult to attain. Why don't we do just one more from the live stream, and then I think we better move on.
So, this participant asks, how do we de-identify the data to prevent sensitivity and privacy concerns if we want to match social media data with survey data?
Yeah, so I think the first thing is, you know, where the question is, how do we de-identify the data if our goal is to match or if part of our analysis is to match the survey data to the social media data. I think, you know, there's ways of adding, you know, of binning, for example, observations. So for example, you may be doing a study of, you know, negative affect in discourse about eating disorders online, and that's a very sensitive data point that you could, like, for example, link young people to their online behavior. You certainly would want to think very carefully about somehow allowing people to identify those people. But if you had a very big bin, something like negative comment, you know, these are things that I think can, like, with reasonable safeguards, and if you've, for example, pre-registered how you're going to define these using the principles of open science, for those of you who don't know them yet, then you can give us as a community some confidence that you're creating reliable measures. But at a certain point, I think erring on the safe side is really advisable. And it will be a situation-specific solution, and again, hold yourself to standards higher than IRB, consult your colleagues, and take the user's perspective. I think those are the best recommendations. Okay, I think we better move on.